video, I'm going to build on what we discussed in a prior video and talk about Unit 7, Day 4, Lesson 2B, when and why do we write quadratic equations? What does solving a quadratic equation mean? And we're going to really dive deeper into how to summarize this lesson and drive home this focus question and understanding for students. So I'm going to just pop up the Desmos lesson. So this is a Desmos lesson that was discussed in the previous video. It's just that lesson from the Google Slides screenshotted into the Desmos platform. And we're going to focus on question 5 for the summary. The reason I chose question 5 for the summary is because it's a question that was accessible from learning from the previous unit, being able to identify the zeros of a function with the question, at what price or prices would the school collect $0 in revenue from a raffle sale? But it's also a key focus question, a key question to focus on because it is listed in the illustrative mathematics lesson plan as a question that is really important for students to understand. So it's featured here. So the second question on this slide 13 or slide B, this is also featured as an important question for students to understand. However, if you notice, it does ask students to explain how they would find out what the two prices are if a revenue was $500. It doesn't actually ask them to find the prices. That's because a lot of students may not be ready to do that because you would have to solve it by factoring, or you could solve it by graphing, but you can't solve it algebraically without factoring. Whereas in this one, you can solve without factoring, simply using the zero product property. Students would not have learned, for the most part, zero product property yet. However, they may be able to figure it out, or some of them may be able to figure out, and that's what we can start talking about in our conversation of the summary. So I'm going to go back here. I'm going to go to the summary, and I have 3 students' work. Usually you would have multiple students' work on the screen. You can choose which student work to feature based on the type of conversation you want to have. For this video, the conversation I'm going to facilitate is one that kind of scaffolds up the strategies using a concrete concrete representational abstract strategy way of running a summary conversation. And what that means is I'm going to go from the most concrete, most, I guess maybe for lack of a better word, simplest strategy to the more complex, algebraic abstract strategies. And so these are the 3 students' work I'm going to feature. So my first student's work I'm going to feature is right here. So I'm going to take a picture of this. And so on Desmos, you have the ability to take a picture of student work. I'm going to take a picture of this student's work. And I'm going to take a picture of this student's work. I'm also going to take a picture of this question and try to add that in as well. Okay. So if I go to snapshots, I have all the snapshots here of the student's work, student A, B, and C, and I'm just going to add the photo I just took. So I have that question in there as well. Okay. So I can add snapshot. So I'm going to add the question there. And then I'm going to add student C's work. And that's because student C did something, used something from previous learning, built a graph. They show it really, they show it in a representational way, the solution to the problem. And then I'm going to feature student B's work. And I'll go through this work in a second. But student B used a guess and check strategy. Student B substituted 40 into the equation, tried it out, got an answer, said it was 40, tried 20, said it was not 20, and then just found an answer of 40. So they forgot to find 0, which is a misconception that happens a lot. So this is featuring a misconception and this strategy of guess and check. And then I'm going to feature student A. And student A used zero product property and actually solved algebraically, and this is what we want to push students towards, so we'll feature that last so they can start to make that connection. And then we just might say, what do you notice? What do you wonder? Sorry. right? And so asking what do you notice, what do you wonder to students is just going to prompt a conversation. Okay. And so we would bring students back together. We would then go ahead and present and share our screen and give students a chance to discuss the different strategies that came about. And when you ask what do you notice and what do you wonder, you really might get a lot of the information drawn from students that you're looking for. However, you can also ask follow-up questions to push for that deeper understanding. So in this situation, students might start saying, I noticed this student used a graph. I noticed that the x-intercepts are the solutions, are the two prices when the school would collect $0 from revenue sales. Why does that make sense is a question you could eventually ask. It makes sense because, right, if I sell if I charge $0, I'm not going to make any money. What about $40? Why aren't they making any money? Well, maybe people are choosing not to buy it because it's too expensive. Okay, great. How might they have created this graph? Well, they might have used a graphing calculator tool. They might have created a table. What do you wonder? Can I always use this strategy, right? There's multiple things students could have said. We really want them to just see that they can connect this to a previous unit, use their understanding of graphing quadratics to identify the zeros and identify the prices that the school would collect $0. And also notice that, right, we can push this understanding too. This is a symmetrical relationship. There are two values that make this equation true. Okay. Next slide. What do you notice? What do you wonder? I noticed that they use I noticed that they use the guess and check strategy, right? And you will give them think time before this. You can prompt them to answer through the chat. You can prompt them to answer just by unmuting. So they use guess and check. They didn't find the answer to both values of P that make it true. Why not? What might have happened? They tried 20. They realized it didn't work. Great. What are some shortcomings of this strategy? Why might this strategy be effective? Okay? And just pointing out that it's important to notice why are there two solutions? Parabolas are symmetrical. Quadratic equations often have two solutions. They don't always have two solutions. When might they not have two solutions? If we're looking for the maximum or minimum or vertex. If we're working with a real-world problem and it goes into the negatives, you might only choose one of the two solutions. But this one does have two solutions. And then you can go to the last slide. What do you notice? What do you wonder? And now we're really driving home this idea of zero product property and getting students to think about how to solve using algebra. Why did they say P equals 0 right away? How are they able to figure that out? What do you know about multiplying by 0? What happens to any value when you multiply by 0? If I substitute 0 in here for P, what's going to happen to this whole side of the equation? Oh, interesting. So then why did they do 200 minus 5p equals 0? What were they thinking? Well, they knew that this would be 0, then that would also be 0. Interesting. Why did they choose this equation and not the other equation? And you might choose to feature work of the other equation. What happened when you tried to solve the other equation algebraically? We couldn't. Right? We had to factor it to this point to be able to solve it. And that's something you can gauge based on what you're seeing students show. Okay, and so basically the goal is to really push students to start to make connections to the zero product property, start to see that you can solve quadratic equations algebraically, and start to get them thinking about how you can solve them algebraically using your knowledge of the zero product property. And then also just connecting back to real world situations and always thinking about how many answers does this question have? Is there more than one answer? Does more than one answer make sense? Okay?